Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating V8 optimization that dramatically improved JavaScript performance. It's all about mutable heap numbers and how they turbocharged the V8 engine. Get ready!
Wow, sounds intense. What's the core issue they tackled?
The problem was a performance bottleneck in the async fs benchmark, specifically within its custom math.random implementation. It was surprisingly slow.
A custom math random? Why would that be a problem?
Right. This math random used a seed value stored in a V8 script context. Each call to math.random updated this seed, and because the seed was a standard, immutable heap number, it caused a ton of heap allocations and garbage collection overhead. Think of it like constantly creating and discarding tiny objects, a huge waste of resources.
I see. So immutable heap numbers were the culprit? But why not just use a different data type for the seed?
That's a great question. The issue wasn't just the allocation. It was also the floating point arithmetic. Even though the math.random calculations were integer operations, the compiler couldn't optimize them because the seed was a heap number. It was forced to use slower floating point instructions.
Ah, the type system hindering optimization. Classic. So how did they solve this?
They implemented a clever two-pronged approach. First, they added slot type tracking to the script context. This lets V8 know the type of data stored in each slot, SMI, heap number, or something else. Then, they introduced mutable heap number slots. Instead of pointing to an immutable heap number, the slot owns the heap number, allowing in-place updates.
In-place updates. That's elegant. But how did they handle different number types?
They also added mutable heap int32 support. If the number fits within an int32, it's stored as such. This is crucial, because the math.random seed always remains an integer. The compiler can now see this and generate highly optimized integer instructions. No more floating point overhead.
Brilliant! So it's a combination of better type tracking and in-place updates that led to the performance boost. What were the results?
Amazing! A 2.5x speedup on the async fs benchmark. That's a huge improvement, and it even contributed to a 1.6% improvement in the overall Jetstream 2 score. A small change with a massive impact.
Incredible! This really highlights how seemingly minor code details can have a huge effect on performance. It's a testament to the power of targeted optimization.
Absolutely. And it shows that even seemingly simple code can hide unexpected performance bottlenecks. This optimization is a great example of how deep understanding of the underlying engine can lead to significant performance gains. Thanks for joining us on Tech Bytes and News. We'll catch you next time. Goodbye.
Bye-bye.